Our next reaction is with Grignards, and this is going to be one of the most useful carbon-carbon bond forming reactions that we cover for ketones and aldehydes. Now, we previously looked at the reaction of Grignards with epoxides. If we had an epoxide that underwent a reaction with methyl magnesium bromide followed by an acid workup, this is the product we got out of that reaction, where we know that our Grignard reagent acted as a strong nucleophile and could open up that epoxide at the less hindered carbon, and that gave us this product after the acid workup. So that this is the new carbon-carbon bond that we formed through this reaction. We're also going to use our Grignards in the reaction of carbonyl compounds in order to form carbon-carbon bonds as well. So this is going to be a carbon-carbon bond forming reagent. We already know about the reaction of Grignards with epoxides. As we continue to go throughout our discussion of Grignard chemistry, we will also talk about the reaction of Grignards with aldehydes, ketones, acid chlorides, esters, and carbon dioxide. The first one we're going to talk about is the reaction of a Grignard in the presence of an aldehyde. So if I have an aldehyde like this one, I could treat it with methyl magnesium bromide, followed by an acid workup, and the product that I get out of that reaction is a secondary alcohol that looks like this one. So I'm starting with an aldehyde as my starting material. The product that I get out of the reaction is a secondary alcohol. During the course of this reaction, I made one new carbon-carbon bond, and so this CH3 group from my Grignard reagent is this CH3 group in my product. So I took an aldehyde to a secondary alcohol. I want you to pause the video and think about the mechanism. Think about what you know about the mechanisms of aldehydes, the mechanisms of Grignards, and see if you can come up with the mechanism for the formation of this product. So let's work through the mechanism for the formation of this product. What we know about our Grignard reagents is that they are strong nucleophiles. So in this reaction, I have no acid until the very end at my acid workup. So in this reaction, I have my aldehyde in the presence of my strong nucleophile, which is my Grignard reaction. My acid only comes in at the very end of the reaction. During step 1, there is absolutely no acid present in this reaction. In fact, what you know from lab is that if there's any water or any source of hydrogen, it interferes with the progress of this reaction. So my strong nucleophile from my Grignard reagent is going to directly attack the carbon of my carbonyl and give me a tetrahedral intermediate. The tetrahedral intermediate that I have looks like this, where this is the new carbon-carbon bond that I have made. And what we know about tetrahedral intermediates is that if they can collapse, they will. But if I look at this tetrahedral intermediate, it has no groups that it can lose. I can't collapse this tetrahedral intermediate and lose a carbon-containing group or a hydrogen. So this intermediate is stuck. And so this is stuck until I bring in my acid workup. So this is what I have at the end of step 1 in my reaction. This will sit around in my reaction. I'll have a magnesium bromide counterion here for this oxygen, but this will be present in my reaction until I introduce that acid workup. So only in step 2, when I introduce that acid workup, will this now pick up a proton and give me my final product, which is the alcohol. I can also look at the reaction of a Grignard reagent with a ketone. So in this case, if I have a ketone like this one, and I treat this ketone with ethyl magnesium bromide, followed by an acid workup, the product that I get out of this reaction is this one. Where my ethyl magnesium bromide brought in this 2-carbon group, and that made a new carbon-carbon bond out of this reaction, and that when my ketone undergoes a Grignard reagent, the product that I get out of this reaction is a tertiary alcohol. And one of the things that you do want to note about this tertiary alcohol is that it does have 3 different carbon-containing groups. And that's going to be important when we get into the synthetic strategies of using Grignard reagents for products that we can make. You should be able to work through the mechanism for this reaction on your own and make sure you can do that. The next reaction we can look at is the reaction of a Grignard with an acid chloride. So let's look at an example where we have this 3-carbon acid chloride undergo a reaction with methyl magnesium bromide followed by an acid workup. Before I give you the product of this reaction, pause the video, think through the mechanism, and see if you can come up with the product of this reaction. Remember that tetrahedral intermediates collapse when they can kick out a leaving group. Tetrahedral intermediates remain when they don't have any leaving groups. Pause the video and work through the mechanism to predict a product. So that as we work through the mechanism for this reaction, I have my Grignard reagent, so methyl magnesium bromide. My carbon-containing nucleophile will attack at the carbon of the carbonyl, kick the electrons up to the oxygen, and that's going to give me a tetrahedral intermediate. I made my first carbon-carbon bond out of this reaction, but when I look at this tetrahedral intermediate, I notice that I have a leaving group. I know from my reactions of acid chlorides that anytime I had a chloride present in a tetrahedral intermediate, it was capable of acting as a leaving group, and this is no different. Due to the presence of the chloride in this tetrahedral intermediate, this tetrahedral intermediate can collapse, kick out that chloride, and give me a new intermediate, which is a ketone. We saw in our previous reaction that ketones react with Grignard reagents as well. So during the course of this reaction, once this ketone forms, this ketone will react with another equivalent of my Grignard reagent and give me a new tetrahedral intermediate. This tetrahedral intermediate is now stuck. It has 3 carbon-containing groups, so there's no leaving groups that it can lose. So this is what I have at the end of step 1 in this reaction. In step 2, when I introduce my acid workup, this oxygen will pick up a proton and give me my final product out of this reaction, which is going to be a tertiary alcohol. Now, as we think about the product of this reaction, it is a tertiary alcohol like this one here. And during the course of this reaction, we made 2 carbon-carbon bonds. I made a carbon-carbon bond to that methyl group and this methyl group as well. So I made a tertiary alcohol out of this reaction, and I added 2 identical carbon groups in this reaction. I made 2 carbon-carbon bonds, and they were with identical groups. Next reaction that I can look at is the reaction of esters with Grignard reagents. And in this case, let's look at the following reaction. If I have this ester undergo a reaction in the presence of methyl magnesium bromide, followed by an acid workup, the product that I get out of this reaction is this one. Make sure that you can work through this mechanism on your own. This mechanism will be a part of your homework, so make sure you know how to work through this mechanism. Just like what we saw with the acid chloride, in this reaction, the product that I form is a tertiary alcohol, and during the course of this reaction, I introduced two equivalent of my Grignard reagents, and I made two carbon-carbon bonds. So once again, I added two identical carbon groups. Make sure you can work through the mechanism of this on your own. And remember that step 2 happens only after all of that Grignard reagent has reacted. Once you have your Grignard reagent in the presence of the acid, your reaction is done. The next reaction is a little bit of a unique reaction, but it's one that you did in lab. In lab, you took bromobenzene, you treated it with magnesium, and you made phenyl magnesium bromide as your Grignard reagent. At the end of that reaction, you added your Grignard reagent to dry ice or solid carbon dioxide, followed by an acid workup, and the product that you made out of that reaction was benzoic acid, like so. So that during the course of this reaction, this carbon from your carbon dioxide is now this carbon of your carboxylic acid product. So the product that we made out of this reaction is a carboxylic acid, and during the course of this reaction, we also added one carbon to our Grignard reagent, so that this can be a useful reaction in synthesis if you need to extend the length of your carbon chain by one carbon. Make sure you can work through the mechanism for this reaction on your own. So our next set of reactions is going to be the reactions of our ketones, aldehydes, acid chlorides, and esters with alkyl lithiums. And what we already know about alkyl lithiums when we saw them way back with epoxide chemistry is that they behave the same way in our reactions as Grignard reagents. So you should be able to look at each of these reagents with the alkyl lithium in combination with the aldehyde, the ketone, the acid chloride, and the ester, and you should be able to predict the products of each of these mechanisms and work through the mechanisms for each of these reactions. For now, I want you to pause the video and predict the product for each case. In these reactions, my aldehyde made a secondary alcohol, and I introduced one new carbon-carbon bond. For the ketone, my product is a tertiary alcohol, and I introduced one new carbon-carbon bond. For the acid chloride, my product is a tertiary alcohol, and I introduced two new carbon-carbon bonds. And remember, it's important to recognize that these carbon-carbon bonds that I made are with identical groups. That will have significance later on as we get into synthesis. For the ester, I see the same thing. My product out of the reaction of the alkyl lithium with the ester is a tertiary alcohol where I made two carbon-carbon bonds, and those carbon-carbon bonds were with identical alkyl groups. So if we start to think about Grignard reactions in the context of synthesis, I want you to look at these problems. In the first one, I want you to take benzene, carbon dioxide, and 1 propene in order to make this alcohol. In the second reaction, I want you to propose 3 different Grignard reactions that you could use in order to make this target. In number 3, I want you to propose 2 Grignard reactions that you could use in order to make this target here. Think through all of these. Solve these. I'll post the solution on Blackboard. You will also see this handout posted on Blackboard. This is a handout that gives you some practice and a summary of all of the different things you know how to do with Grignard reactions. Look at this handout, go through this handout seriously as a review of all of the things we know how to do with Grignard reactions. We could do a reaction with a Grignard reagent and formaldehyde, which is a specific 1-carbon molecule. We could use any aldehyde like this one here, any ketone like this one here, any ester, acid chloride, carbon dioxide, an epoxide, and what would happen if I treated this compound here with a Grignard reagent? Think very carefully about this compound.